Hello and welcome back to Math 8. This is a video over Section 9. What we're going to be doing is comparing slopes and y-intercepts of equations and graphs and tables. So our objectives today, we want to determine slope and y-intercept of linear functions represented differently. Compare the slope and intercepts of linear functions, including when they are expressed as equations written in different forms. So we have different representations of linear functions, okay? And in this example, we talk about a linear function that has a slope of -1/3 and a y-intercept of 2. So what we can do is we can express that using a table. We can show the same relationship using an equation, and we can say the same thing using a graph. So all three of these, and so let's write this down, that all three represent the same thing. Represent the same thing. Okay, they're just different ways of representing that relationship. Okay, so what I want to do is compare. Talk about how we compare slopes. Okay, and what we do is we can, we can talk about whether a slope is positive or negative or not. But what we do want to talk about is the steepness, okay? And we talk about the absolute value of the slope. So what I want to do is let's write down some various slopes here, okay? And all of these slopes are going to have a y-intercept of 0, okay? So let's just write down a couple. Let's write down m is equal to 1. Let's write down that m equals -1. Okay, let's write down m is equal to 2. Let's write down m equals -2. And let's write down that m equals 1/2, and then m is equal to -1/2. All right, so we're going to have quite a few lines being drawn here. So when m is equal to 1, I'm going to use the color red and -1. When we have 2 and -2, I'm going to use blue. And then 1/2 and -1/2, I'm going to use green. Okay. So when I have a slope of 1 or -1, what I'm going to do is this. I'm just going to start here at 0, and I'm going to draw my line up 1 over 1 going in this direction, and then going down in this direction, okay? Now, if I drew a slope of -1, okay, we would have a very similar thing, okay? And what that would do is it would look like this, okay? And I'm just going to draw it like so, okay? The next one I want to do is m is equal to 2, okay? Now, what I know here is that if I draw this slope of 2, I'm going to go up 2 over 1, okay, or up 4 over 2, since we have a scale of 2. I'm just going to draw these lines going like this, okay? And that's my slope that way. Now, I'm going to draw the same slope going in this direction. Make sure I'm hitting the points I need, or being close at least, okay? And that's the idea, okay? Now, what I know... and then I'm going to draw these lines here. Okay, I'm going to draw the ones in green. So up 1 over 2, up 1 over 2. I'm just going to have a graph that goes like this. Boom, boom. All right, so one that goes like that. And then another one that goes like this. Okay. And so here's what I got. And what I notice is this. All right, and I'm just going to talk about... these lines here. Now, what I notice is about the, if I look at each of my red lines, okay, and I'm just going to, label this here as my slope is equal to 1. First of all, the thing that I notice is that it doesn't matter whether the slope is 1 or -1, okay, and I'm going to come down here and write this as m equals -1, okay. It doesn't matter whether the slope is positive or negative, but they have the same measure of steepness, okay? And that's what I'm concerned with, is just measuring the steepness, okay? If I look at the slopes here in blue, where the slope was m was equal to 2, and then here m was equal to -2. Okay, these slopes have the same steepness. They're just oriented differently. Okay, and then this slope, m is equal to 1/2, and then here m equals -1/2. Okay, they have the same slope. They're just oriented differently. So steepness, so let's write this down over here. Steepness does not take the sign of the slope into account, okay? Into account, okay? And what I mean by that is that the sign doesn't really matter, okay? The sign doesn't matter. What we're looking for, if we're talking about which line is steeper, is we're simply just looking for the size of the number, okay? And what you can do here is you can look here and say, all right, even if I have a slope of -2, all right, this line here, it's still going to be steeper than a line that is, 1/2, a slope of 1/2, okay? And here's also what I know, okay, is that the bigger the slope, okay, the bigger the slope, the steeper the line, okay? The steeper the line. And that's what I'm really concerned with is just analyzing that. And when I talk about steepness, what I'm talking about is like, which one of these would you, if you were going downhill in whatever direction, would you be going faster? Okay, and that's, your measure of steepness, okay? And you can kind of think about, green slopes versus blue slopes versus, black slopes when you're skiing, okay? Same kind of idea. Black slopes, they're steeper, okay? And that's why they have that color rating to say that, hey, this is a hard, difficult, steepness of a slope, and so you're going to go faster, okay? So you have to be a better skier to go down those. So, all right, so that's what I got. All right, so now let's talk about Y-intercepts. Okay, so comparing Y-intercepts, okay, we locate the Y-intercepts of a linear graph represented on the graph, and we can locate them on an equation. We want to know which function has a larger Y-intercept. So here, and Y-intercepts is a little bit easier. You're just looking at the value and saying, well, which one's larger? So here, my B value is equal to -2. Okay, now that's locating that Y-intercept from this graph. Now, if I locate the Y-intercept from this equation here, it's going to say y equals 3x plus 4. So I'm going to go up here to 4, plot my Y-intercept, and we can graph this and determine, what we've got. And let me zoom out and draw this line. Okay, so we've got parallel lines, okay, and that's all fine and good. However, we've got this concept of, where is this Y-intercept? Okay, so this Y-intercept up here is that B is equal to 4. And so which function has a larger Y-intercept? So the function with a Y-intercept of 4 is larger, okay? And you're really just looking for those values and determining which one's bigger and which one's smaller, okay? All right, let's look at the next page. Okay, so what we can do is we can look at two different functions. So I have this function here, given by this table, and then I have this function here where we have a graph, okay? And what I want to do is compare first the slopes of the data in the table and then the one in the graph. So let's calculate the slope here real quick, okay? And here's what we can do. I'm going to use the point 1, 1, and 3, 7. So I'm going to write those down, 1, 1, and 3, 7. And I'm going to write my slope down. And my slope is going to be m is equal to, let me label this x1, y1, x2, y2. So I'm going to label it as 7 minus 1 over 3 minus 1. And so that slope m is going to give me 6 over 2. And so that slope is going to give me 3, okay? And so that's my slope for that graph, okay? Now over here, what I notice is that I can do the stair-step model to figure out from point to point what my slope is, okay? And so I can go from my rise and then my run, rise and then run. And what I notice about this is a couple of things. Number one, the scale on my x-axis is different than the scale on my y-axis. Notice on my x-axis how these go up by 2s, okay? Notice how on my y-axis these go up by 1s, okay? So here's what I've got. I know that my rise is 1 and my run is 2. Okay, so here I actually have a slope of m is equal to 1/2. Okay, so what I know is that the slope in the table is larger. Okay, therefore the slope is steeper. Okay, now even if this was a -3, okay, it would still be steeper than, say, 1/2. Okay, so we're just looking at the value of the number. We're not looking at whether it's positive or negative or not, okay? Okay, the next one says find the y-intercept of the linear function from the data in the table and the y-intercept of the function expressed in the graph. So in the table, or in the graph, I mean, the y-intercept here is equal to -1, okay? So my y-intercept here, b, is equal to -1, okay? So let's do this. Let's talk about, you know, in the graph, let me just write this down, that my y-intercept b is equal to -1. Okay, now the other thing I want to do is I'm going to use this point because I can't readily figure out what my y-intercept is here on my graph because I don't have an x value of 0. So what I want to do is I'm going to write my equation here to figure out my y-intercept. So I know my slope is 3, okay, and I know that my that I have a 0.11. So let's find that y-intercept here real quick. So I know that my slope is equal to 3. I know that x equals 1 and y equals 1. I'm going to use y equals mx plus b to figure that out. And so what I'm going to do is I'm going to plug in 1 for y is equal to 3 times 1 for x and then plus b. So I've got 1 is equal to 3 times 1, which is 3, and then plus b. So I'm going to subtract 3 from both sides, okay? And I get -2 is equal to b. All right, so I find that in my table, so the slope in the table, or I'm not my slope, my y-intercept. So my y-intercept in the table is smaller than the y-intercept in the graph, okay? All right, so my graph has a larger y-intercept. So graph has a larger y-intercept, okay? So you're just looking to see, okay, which is bigger? Is your, you know, if you compare two equations, is your slope bigger in one or the other? And then, you know, your ability to then analyze the y-intercept as well. So given different representations, that's how we do that. So I hope you enjoyed this video. Hope you learned something, and we'll see you in a bit. Thanks a lot. Bye.